Hello and welcome to the channel. So while I was down at the shop taking some repairs back a couple of weeks ago, I picked up this THD hot plate down there, saw it, and I thought that'd make a good video for the channel. So I lifted it into the car, so to speak, and we've brought it for all you viewers to have a look at. So some of you've probably seen one of these before. This is a THD UniValve, a single-ended guitar amp. Now THD, and I've got one of the hot plates, so I know normally THD makes some really great gear. So it's what attracted me to this amp when I saw it, having one of the hot plates, and you've seen me use that on the channel when we've been looking at bigger amplifiers. So this has got the hot plate built into it, the attenuator on the front by the look of it. And this is a very interesting amp because UniValve means that you can use, as long as the pin out's the same, you can use any Octal tube as the output tube. And I'm looking in there and I think that's a 6V6S that's in there. Now it's a JJ, but we're going to try some various tubes in this amp. But we're also going to do some tests on it because there's one or two things that I'm wondering quite how they've got around. Well, apparently it biases automatically, and you can put some very different tubes in this amp. So I'm kind of looking at exactly what tubes you can put in this. So 6L6 EL34s, sorry, that's misread that. It's 6L6s, EL34s, 655Os. Each type of tube has its own unique characteristics according to the gump that I've actually pulled up on this amplifier. But also these tubes have different dissipation. So for instance, a 6L6 has a dissipation of 30 watts, and EL34 has dissipation of 25 watts. But this amp is supposed to have an automatic bias system that automatically biases the tube. Now it's cathode bias, it's single-ended, so it's not that critical, is it, really, for, you know, to get, it's not like we're dealing with class AB and more, which would be much more complex, and we you know, we could be sticking some tubes in and ending up with a load of crossover distortion. That's not going to happen on this amp. But I was just interested in this, and I just wanted to have a look, take the lid off it and look inside it and just see, you know, how well this amp's made and how well it performs. So let's have a look at the front first of all. So we've got the usual power switch, and we've got a standby switch, as most amps seem to have nowadays. We've got a low and a high setting, not quite sure what that does yet. I presume that's half power thing, I don't know, but we'll look at that. And then we've got a full power switch, we've got the hot plate attenuator, and you can see that arrow there going down to the attenuator. What we got here, noise reduction on there, not sure how that's working. I wonder if we can find a schematic for this, you know. It would be handy if we could. I'm going to have a bit of a search online. Now this is a bit of a funny font on these. I'm just trying to read that, what that actually says on there. Does that, let's say amplitude or something? Bass, treble and volume, and I would imagine that's, I don't know, is that some kind of attenuation? I don't know what, but anyway. And the input sockets are quite unique as well. We've got rock and we've got roll there, so I'm liking this. It's almost tongue-in-cheek, isn't it, this amp? Let's spin it round and have a look at the back there. So what we got on the back then, let's have a look. We have 15 watts RMS. Yeah, of course it will be if it's some of the tubes that are in there. I don't think you were getting that out of a 6V6 though. 8 to 16 ohms or 2 to 4 ohms. So this is a very versatile amplifier there. And we've got a line out level, line instrument, usual deal. Not many guitarists use those because we always mic up. Well, I do anyway. So filament fuse there, 3 amp, and HT fuse slow load there. We've got the mains fuse, usual deal on the back, serial number 0915. So I think we'll take the top off now. If we look at the sides, you know me wincing picking it up, it's reasonably heavy. We can just take these, you can't see those on the camera, just lift it up a shade. You can see those there, so we're going to take those out. So you get, I think you can get that, and that's really good how they've done these. You used to see that a lot. Let me just bring the camera down. You used to see that a lot on real old vintage equipment where you screw these out, but they stay fixed in there. That's a brilliant idea. So there's no chance of losing those. So let's take the other side off. Oh, look at this. This just comes off so easy. Up there. And look at that. My word, we got that off pretty quickly. So that's cool. Really well made, sturdy cabinet as well. Right, so I'm going to turn it back round to the front. We're going to look over the top. Right, so we're looking over it now on the top, and you can see we've got various tube. Right, so we're looking over the top of this amp now, and you can see we've got various choices of tubes here, for the preamp tubes, and same for the output tube as well. So we've got a 6V6S in this at the minute. What have we got in here? So we've got a 12AX7 in there. And I'm presuming we'll have the same in here. We can get the doofer off. There we go. Yep, same thing, 12AX7. So preamp tube wise, on this amp, we can have 12AX7, 7025, ECC83, which is the same as a 12AX7, and then 12AT7, a 6201, not heard of that tube before, ECC81, which is a 12AT7, 12AU7, and ECC82 is the same, and I don't know whether I presume maybe then 5814 is the same. So really it's the usual deal, AX7, AT7 and AU7. So the output tubes are more interesting. 6550s, 6L6, 6CA7, 5881s, EL34, KT90, KT88, KT77, KT66 and a 6V6. 6V6, that says, what does that say? Low V only. So if we give this a bit of a clean up as well while we're here. There's one disadvantage of having the grilled top, the dust does get in there, but we can clean that off, it's no problem. So that's all looking good. So this is what I'm saying about this amp. The difference between a 6V6 and a KT88 is massive. Even between, you know, something like even an EL34 and a KT88, there's a pretty big difference in dissipation in those. I think I've got a KT88 somewhere that we could try in this amp. Be interesting to try all these different tube configurations. So I'm going to remove this 6V6S, because what I'm going to do now is I'm going to tip it over and I'm going to take the bottom off it so we can have a look inside. Now, we're not expecting to see this hand wired or anything. You know, we know it's going to be PC board extravaganza in here, but even so, we'll open it up anyway and have a look. Right, I've got the bottom off it, and I'll tell you what, this ain't a badly designed thing at all. So these PC boards are really thick, real good quality, not the flimsy crap that you usually see. Now you've got some small capacitors here, but don't see any surface mount you know, components or anything. Oh, we've got a bit of a burnt resistor there though. R14. That looks a bit sizzled to me. Is that? Going to 1, 2, 3. That's pin 6. I wonder if that's a plate resistor, you know. It's very sizzled. I think that's going to pin 6 anyway. They're very close together. I could test that with a meter. That might be a plate resistor. That looks like that's had a bit of... Oh, and look at that one as well. Is that one the same? That one's had a bit of a baking. R8. That also looks like a plate resistor. We need to check those on Bully's prize board, don't we? So let's just have a look. Let's try the first one we spotted. What is that resistor? Let's test it. 135k. I can't really see it. It's so burnt. I have to get some bigger glasses on and have a look. That looks like orange to me. But they're the four band resistors there, so that will be 100k then, 135k. I think that's, yeah, I think that's brown, black and orange, which would be the equivalent to yellow on a 3-band, and that says 135k, so he's gone up in value. Let's try the other one here. He's 110. So those two resistors are not okay, and they are not a lumberjack. As we pointed out on a previous video, he's a lumberjack and he's okay. He's not a lumberjack and he's not okay. He's toast by the look of him. Let's try this one here. Yeah, that's definitely connected there. Yeah, that's definitely pin 6. So that is a plate resistor. Yeah, 100, and there you go. You can't see the meter, but 110 on there. See if we can put this meter in shot as well. There we go. So if we look here on the meter, if we test there and there to that wire that's going to pin 6, you can see that we get continuity there. If we test, so here and here, if we test to the wire and the front of the resistor, we get the same. And if we test to the other end of the resistor there, we get the 110, which is same as what we get here. So that resistor is a plate resistor, and that is quite badly burned. It's definitely gone into toast mode, hasn't it? So I presume that one's the same there. Yep, so that's also a plate resistor. So I think we need to change those, don't we? Because that one's 135k, so it's definitely gone high in value. So they're 100k, I think. I will see if I can find a schematic, but yeah, apart from that, found those, but that's no big deal to change those. But this, I mean, apart from the half-watt resistors, this don't look a bad thing at all. As I say, these boards are solid, absolutely solid, really thick boards, so that's really good. Looks like all the capacitors are underneath on this board, and you just have to drop the screws out if you want to change them. It looks very easy to service and maintain. So to take this board out to swap those resistors, you've just got the 4 screws there. On there, we've got these. We'd have to. So probably the best way to get this out, or are they? Oh, I can do those from the top, can't I? Because yeah, it's a double-sided board. Just realised. Don't have to take, so I can do those from the top, so that's even better. Swap those. So this amp has been well thought out, really, because it looks very, very easy to maintain. So we've got a couple of, let's find a pointer or something. We've got a couple of big chunky resistors on here as well. Got a capacitor here. See what pin that's on. Got another resistor on that tube base there as well. These are beefy things. Looking at what pin we've got. Is that 1, 2, 3, 4? Is that that pin 4. So that is that a screen resistor. Oops, with the camera, sorry. That screen resistor, and this one looks like it's going to ground on there. So let's have a look what that's doing on the schematic. But there, beefy resistors. Look how well these fuse holders have been insulated as well. Really, really, really quality workmanship in this amp. Despite it being a PC board amp, there's some real quality workmanship in here. Some of these, the way some of these have been soldered aren't so clever though. Just laid the wire across there when you could have really put it through. They flattened all the pins down, look, to keep them away from each other, but maybe it'd have been nicer if they could have done with it. I presume that's factory. Maybe it's not factory then. Maybe somebody's had this board out already. Somebody may have had this board out as well. That doesn't look very factory to me either. So yeah, this looks good. This looks good inside. Look at the big attenuator pot there. Look, this is just. See if I can just swing the camera down into there a bit more so you can see it. Here, look, this big attenuator. That's for the hot plate. Look at that for a beast. That's a serious bit of kit, that is. Yeah, so that's good. Nice. There's some nice kit in this. It's, you know, you can see that this amp, as I say, despite being PC board, you can see that a lot of good components have gone into this amp. A lot of good work. You can't see what make the caps are because they're underneath, but very well made indeed. Well, I think it is anyway. And this was made on the 15th of April 2002. So I didn't expect it to be quite as old as that, but let's just bring the camera back. But yeah, very clean inside. Very good bit of kit. Little transformer or inductor on there. Not sure what that's doing. That could be something to do with that line out thing on there maybe. Yeah, so all good apart from those two resistors there we've found that are a bit burnt. Might have to just measure what's going across those and just see if they're underrated. Strange that both of them are like that. Normally if you see one like that, you could, you know, you could kind of say, you know, maybe it had a tube in it that shorted inside or something that caused some current, but both of them. So I think the next thing we can do with this is do some readings. So find out how much plate voltage it's got and see if we can find out how it behaves with different tubes in it. The different output tubes. The preamp tubes are a bit pretty, we all know, don't we, what you know, you just get less gain if you put the 12 AU7 in there. So I'm just looking, is that that's the primaries, is that the primaries? Where's going to the speakers socket on the back? Is that the speaker socket there? No, that's the line out. Speaker socket's in this corner here. So this is the primaries on there. So where's that going? Oh, one's going to the tube, that's right, pin 3. So the other one will be going over to the caps, I'd imagine. I can't see where that comes through there. It's very well hidden, that wire. But I think I've just spotted it coming round there and into there. So what's this resistor here? 3, 4, 5 is the grid, 6. So that's the grid coming in and the grid stopper here. So let's get it plugged in and just see what I'm going to plug it. I think I might put it on the scope and just put the hot plate on it as a dummy load. Right, so I've got this amp on the scope and I've got all the attenuation off and everything, just running. I sprayed a couple of pots that were scratchy on the oscilloscope. They were showing us they were dirty pots, so I've cleaned those. So we've got a 6v6 tube here that's, I'd pretty much say, is pretty much steaming. The 6v6 only being used on the low setting. Low setting. Now that's dropped the plate voltage down to 304 volts. And that's the more the voltage I'd expect to see on a 6v6. So if you flick that off, that low to high setting, you've got a tremendous amount of voltage on that 6v6. So all I can see that's biasing this amp is a cathode resistor there, the very large one. If we go in, you can just see that the top of the side of the bypass capacitor there is it's on its end, and you can see the cathode resistor at the side of it there. Go in, and you can see they've used pin. Just come around here. You can see they've used pin 8. Obviously, pin 8 is the cathode, and they've used pin 1. There's no connection to mount the cathode bypass capacitor onto to ground. I don't see any other wires coming from that cathode going anywhere else. The big resistor on the left is the screen resistor to the left of the cathode bypass capacitor, and that's all I see on there. So that's telling me that this amp's just got a simple cathode bias on it. So we've got 22.7 volts drop on that high setting, and we divide that by our 307R. Take 5% off for the screen and times it by our plate voltage, which plate to cathode was 420, and that tube is running at 29 watts. So that obviously tells us do not have the 6v6 on the high setting. Now that's good as long as somebody's read the instructions on there, and it did say that on the back. We do remember seeing that when we actually read the 6v6 only works on the low setting. But the way I read this amp, it kind of leads you to believe that this has got an automatic bias no matter what tubes you put in this amp. That's actually not the case. So that tube is being absolutely thrapsed, and the only problem I have with that is you could accidentally switch that switch on. You know, on a gig, it's dark in there. You know, you go to flick the standby switch, but they're side by side. I'll show you what I mean. So if you look there, you can see the standby and the high and low switch are together. So you know you're on a gig. You've just walked on stage. It's dark on there. You're all getting ready to go on stage. So you grab the standby switch and you flick the, you know, as you're doing that, you flick the low to high, and you play the entire gig with your tube dissipated at 29 watts. So that would be something you'd have to take care with, wouldn't it, really? You know, you'd have to watch that, because if you're using a 6v6 in this, you're going to bake it. So now let's do the bias on the 6v6. So the volts drop is 15 volts. 15 divided by 307. Now that's running at 48 milliamps. So what we got plate to cathode now, we should have less than 300 volts on there. I would have thought 289. So we know why you have to have the 6v6 on the low setting now, because we've done the voltage checks. And if you use it on the high setting, or you accidentally switch it on the high setting, you'll be knocking 7 bells of poo out of it. and the 6V6 won't last very long at that, I can assure you. Bearing in mind that once it's cranked up it'll be getting even more swage, so that's something to be wary of with this amp. So now what we need to do is find out what volume is coming out of this amp. Right, so if we look on the scope, you can see we've got the sine wave there, and we need to get it till it's just starting to square. Just go back, you see that it begins to square probably about there. So that's what we're getting out of it clean. Let's click measure, and that shows us we're peaking about 18 volts, I would say there. 9 volts, yep, 18 volts. So 9 volts is what we need, because we need, remember the peak, we need to divide it. The trigger line already does that for you. So that's 9 divided by, what am I talking about? Sorry. Try again. Oh dear. 9 times 0.707 equals 6.363. We need to square that, and we divide that by 16 because that's our hot plate. 2.53 watts we've got there clean coming out this amp. And that you know, someone say, well, that don't sound much, but you know, on really good responsive speakers, that's really loud for a small single-ended amplifier. Remember, that's only what's coming out of it. Speakers that you add onto it, the type of speakers that you put onto it, are always going to make a difference in the volume. You put a low responsive, you know, crappy speaker on here, then it won't seem as loud as putting a really responsive speaker on there. So that concludes for the 6V6. So, and that's probably roughly what we'd expect to get out of a 6V6, I would have thought. So let's turn our attention to another tube now. So I'm going to go off and find some more tubes. Right, so I've got an array of tubes here. So in the big box we've got a KT88. You can see there, it's one of the gold lions. So we've got a Mullard L34, a 6L6 GCR, which is a Chinese tube, which I think only has a dissipation of 19 watts. We've got a 5881, which has a dissipation of 23.5 watts. We've got a 6N3C, which is a Russian tube. I think are all of these, is that many. That's 20.5 watts. And then we've got a 6L6 GC there. Don't have a KT77 or a 66, anything like that, as far as I know. But they're mainly the tubes that we've got to put in this. And I've also got a couple more here that I've just found. I've got a 6F6G, which has a dissipation of 11 watts, and one of the Russian 6V6s, which are dissipated at 12 watts. So we're going to try all of these tubes that we've got here, all of them. Right, we've got the 6F6G tube in there. It's a really old tube, this one, and not many people have heard of that. Some of the older techs will have done. I can't remember where that came from now, how I came by it, but I have it, so nonetheless. So let's just have a look what we can get out of it. Let's just take that down first and just see what. So you see that's just going a bit flat on the top. Now this tube will handle 375 watts on the plate and 285 on the screen, so we're absolutely fine with this tube. We've got a measurement, and you can see there we're getting 14.2 out of that. There must be some people wondering why I'm doing this, and it's because I can. And it's fun, because I just want to see what this amp's capable of. So if some of this stuff's a bit much for you, then you'll better scroll to the end of the video and just start at the demo. And what I'm going to do during the demo is I'm going to try each tube again, but obviously we're going to be listening to it, and as opposed to seeing it on on the scope. I'm just doing the maths on this one. So you get 1.5 watts out of the 6F6G. So again, you could crank this tube, you'd have a real low wattage on there. I mean, you've got the attenuators and things on here as well. So the thing with this amplifier, it's multiple choice. You know, you can put a tube in such as this where you've got, you know, less dissipation, and you're only talking about one and a half watts now. So if you were recording with this and you prefer to crank the amp up instead of using all the attenuation, and I think I would, to be fair, you know, you could do that, so no problem. Right, so let's see what the bias is going to be now with this tube in. So I've just done the bias on that tube and it's 14.35 watts. So when this amp says it's got automatic bias, it depends how you want to interpret that. Some people would call cathode bias automatic bias. I don't. Remember that the tube I've just put in only dissipates at 11 watts, and we're ramming 14 watts into that. Plus now it'll probably run all day long at that. And to be fair, that tube is not on the list, so we can't criticise the amp for that. But what I'm doing here, I'm kind of covering every base. Where someone says, well, this tube's, you know, wired, it's the same pin, I can put this tube in. You can put that tube in and it will run for a considerable amount of time. You know, it might run for a couple of years. It's not massively over, but I've seen tubes push much further than that. All the 6v6 type tubes that you put in this amp, unless they're 6v6S's, they're going to be over biased in this amp, or it's a tube that's drawing very little current. But most of the tubes that I'm using here, you know, the new tubes, and they'll probably draw quite a lot of current. Right, now I've got the 6P3S in, which is the Russian 6v6. These have a dissipation of 12 watts. And you can see we're getting 9.4 volts out of that clean, which is just a smidgen more than the 6v6S, but nothing to even write home about. So we know what that's kicking out, don't we? Because it's kicking out the same as the 6v6S. Also, the bias is going to be the same, I'm guessing, but I'm not going to speculate. I'm actually going to quickly test it. So smoke bottle 6v6 RCA, so that's going to go in. Let's see what we can get out of this 6v6, this RCA 6v6. Should be getting a dissipation of 12 watts, so we'll check the bias in a bit, but we'll try measurement, and we are getting about the same, so no difference. Let's just see. Yeah, about the same, 9.4. That's the same as we got out of the Russian 6v6, so that's good. So let's check the bias now. Right, that comes out at 15 watts, the RCA tube. So again, that's 3 watts over on that. So let's give this tube a try. This is a Brymer 6v6 GT. Right, we've got the Brymer in, and you see we're getting about the same out of that. There's no surprise there, getting the same out of that as we're getting out of all the 6v6s, the 12 watt ones. Right, let's do the bias quickly on this one. Right, so the bias on that comes out at 14 watts. So the RCA is a watt higher when that's in the amp. The 6P6S, the Russian 6v6, is 14.2 watts. The 6F6G, which has a dissipation of 11 watts, is 40.35 watts, but as I've said, that's not in the list of tubes for this amp, so it would be unfair to judge this amp on that tube. I've got the 5881 in there now. Let's just And now it's on the low setting. So now with these tubes, these are the tubes now that we can use in high and low setting. So I've just turn the volume down there so we get bring the trigger down. Now this tube has a maximum dissipation of 23.5 watts, but we're obviously on the low setting with this. So does that mean this tube is going to be under biased? Yes, probably. It probably is. So 17.8, I would say that's peaking at. Getting 2.47 watts out of it. So let's check the bias now while it's on the high. I'm expecting to see 14 watts again. That comes out at 16 watts. Now let's put it on the high setting. And now let's go back to let's see what we've got on the scope now. See how much more headroom we're going to get out of this. So now you can see we're squaring off there. So now you can see just trigger up there, but you can see it on peak to peak on the measure. So now 27.2 we're getting out of that. 5.77 out of that clean. 5.77 watts. So let's do the bias. Let's do the bias on that now. Remember, 23.5 watts is the maximum that we can get, maximum dissipation of this tube. Right, so I've just done the dissipation on that 5881. Wait for it. 37.99 watts. So that tube's dissipating 38 watts. So this is what I'm saying to you. You've got to be careful with these amps. This thing about, oh yeah, I can just put this tube in it. You can't. That 5881 is drawing an excessive amount of current. There is no automatic bias. There is no, oh, I can just put this tube in this amp and it'll work. It won't. That is way over. You know, there's no magic system in this like in the Hughes and Kettner that we looked at, you know, where it's got all this intricate control chip bias setting. This is just a simple cathode bias amp. In fact, this whole amp is simple. And actual fact, I love this amp. Just looking in it, it's a very simple, because obviously from our perspective being a tech, I'm not going to stick any tube in any amp without, you know, checking the bias on it. But not everyone has that luxury, you know. Some people just take what's written on top of the amp as you know, as final. So you know, this amp is a great amp so far. From what I've seen, it's a good amp, but it, you know, there is flaws in this. And this thing about, oh, an amp's cathode bias, you can shove what tubes in it you like, I'm sorry, but you can't. And I've just proved that fact. You know, you can look at the figures, and I'll post these figures at the end in the description. You can look at the figures and look at it for yourself. So this is a Chinese 6L6 GCR. This has a dissipation of 19 watts. Right, so I've got the 6L6 GCR in there. And again, this has a dissipation of 19 watts. Just checking something there. With that full power switch, make a slight difference. Right, now let's have a look at this tube. Now this tube is on the low setting, not on the high setting. So what are we actually getting out of this now? We can move the trigger up. So we are getting a little more out of that. So we're getting 11, 23.4, I think it says 23.2 on the peak to peak. It's just peaking out, I'll call it 23 volts. 3.64 watts we're getting out of that on the low setting. 3.64 watts. Let's just see what that tube's biased at now on the low setting. 18.39. 56.9 milliamps, that's we're getting out of that. I've done the bias on the 6L6 GCR, remember it has a dissipation of 19 watts. The bias on the low setting is 16.2 watts. The bias on the high setting is 37.5 watts. It's not a good idea to run the 5881s or the 6L6 GCR on the high setting, not at all. They're way over biased on that, and I've just put it on the high setting now, so I just want to see really where we get. Better not have it on it for long. It won't like it. Have a look at measure, and we've got about 31 volts peak to peak there. I'm just going to flick that back to low, because and you're getting 7.5 watts out of that clean on the high setting, and we was getting on the low setting, we was getting 3.64 watts out of the low setting. 6P3S. So this is a Russian tube, and these have a dissipation of 21.5 watts. So we're going to pop this in next. This is a brand new one. Right, so I've got this tube in, just waiting for things to warm up. You can see it coming up now. So we've got this on the low setting again. You can see, where are we at there? 11 volts. Well, 22 peak to peak, but that'll be 11 volts. Remember, we divide it by 2. So doing the maths on this one, so getting 3.7 watts out of that on the low setting. Let's check the bias. So on the low setting, we've got 17.7 watts dissipation coming out of that tube. So we can see where this is going, can't we? Flick this, we're going to flick it onto the high setting now. And I just heard it grunt as I switched that on. You could hear the glass suddenly swaging. 29.6 volts drop. So 91 milliamps, 91.5 milliamps with 5% deducted for the screen. So that is pretty substantial. 406 plate cathode. I keep switching it off. And that is also now 37 watts. So the 6P3S Russian tube again, only on the low setting. It won't last long. And if we flick it onto the high setting there, and you can see that tube's got a lot more juice odor, because we're now pushing right up to the top of the scope screen. 34.2 peak to peak. Dropped it back onto low again. 9.13 watts we're getting out of that. 9.13 watts. So if we we'll go on to high, but not for very long. You can see there now, if we go on to low, see it square off there on the low setting. So massively over biasing the tubes makes clean headroom look there, but we wouldn't massively over bias it like that. It wouldn't last very long. I'm willing to bet that tube would only last 8 to 9 hours being thrashed to that extremity, but I could be wrong. I mean, some of these tubes are tough, but you really wouldn't want to be doing that, would you? And it's probably, I mean, this amp obviously can take that sort of current on the power transformer, because it runs a KT88. So just have a feel of that transformer. It's cold. Not even warm. So it's a beast of a transformer, that is. Right, this is a Softec This is a Softec 6L6GC that we're going to put in next. Power dissipation of 30 watts. Right, we've got the 6L6GC on the low setting, and it was still set for the last tube. You see there's a bit of break up there. That sounds like my cat wanting to come in. That's not Pink, that is Beard, the other cat. Yes, Beard. Yes, don't chelp at me, Beard. So, my cat Beard always chelps at me when I go near it or walk past it. Even when I let her in and she walks past, she has a bit of a chelp at me. In other words, she has a bit of a go at me. So let's see where we are with this one. 22 volts peak to peak there. So again, that's roughly kicking out on the low power what the 6P3S was kicking out. That's just about the same. In fact, it is the same. So I think we can safely say that that's dishing out 3.7 watts then. So now we already know that, so now we can go straight on to the bias and check what the bias is. And obviously we're guessing the bias is probably going to be the same as well. Let me just see what we've got there. 19 volts, and we had 19 volts on the 6P3S, so the bias is going to come out exactly the same, I would have thought. So I think we can safely say that that's biased at 17.7 watts on the low setting, which is exactly the same. So those tubes up to that point, they're well matched up to that point, but of course it's when we go on the high setting what is going to happen. So gone on the high setting. Now if you notice when I flick this tube onto the high setting, it's not really gone up a great deal, has it, compared to the other one, which almost went off the top of the screen. So now let's see what we can get out of this tube. About 33.8 is that? 33.8 we could call that. 34. So let's do the maths on that. 8.9 watts we're getting on the high setting. So 8.9 watts. But now the bias. 95.3 milliamps on that tube. Actually, let's take away 5% for the screens. 90 milliamps we've got there going on. 90 milliamps, my days. So what's the plate voltage to cathode? 409. 37 watts. Again, that's dissipating exactly the same. So that's 7 watts over what it should be. So running that tube on the high setting is not a good idea either, is it? Biasing on this amp is kind of not in a window that it should be. So we'll put that back on the low setting. So the next one is going to be the EL34, which is only 25 watt dissipation. So we know where that's going, don't we? So running some of these tubes on the low, so we'll have to read the instructions again, see if I misread that. But running some of these tubes on the high setting, in fact, to be fair, all of these tubes we've tested so far will not run on the high setting, not for very long. They're all way over biased. In fact, I'm going to measure that cathode resistor again, because have I got something wrong here? No, 307.7 ohms. So no, I haven't. Let's double check. Right, this is a Mullard EL34. Let's give this a go. Right, we've got the Mullard EL34 in, and this volume is at the same setting as it was for the 6L6, and you can see that that's already squared off there. Notice something slightly different on this tube really. This one's already beginning to overdrive. It's already beginning to break up. Look, just check the bottom of the wave. And that's the amp flat out. Let's try it on measurement. Let's see what we get in. We are getting 17.6 on there. 2.41 watts, that's on the low setting. That's what we're getting out of the EL34. 2.41 watts. Now let's check the bias. Right, we've got 16.2 watts on the low setting for the EL34, which is pushing up towards 70% of its dissipation. Now going to go on the high setting. Let's have a look where we are now. So we're getting about 31.2 volts peak to peak. 7.6 watts we're getting out of that. So the bias on the high setting for the EL34 is 33.2 watts. That's 8 watts over. So that's massive. So none of these tubes so far have been in the window on the high setting. Right, the final unveiling. Here's the KT88 that we're going to try in here. This is a beast of a tube. Check out that monster. And remember, we had these in the 200 watt Carlsberg PA. You might not remember that, but that's a video that we did last year. So you can see he's a beast. So we're going to pop him in and see how he performs. Right, so I've just put the KT88 in and we're just waiting for it to warm up. Here it comes. That's on the low setting. We'll just warm his loins up a bit before we do the tests. Right, we've warmed his loins, so let's see what we're getting out of him. He's peaking at 21 volts. 3.44 watts on the low setting. Right, let's check the bias on the low setting. So on the low setting, we're getting 3.44 watts out. We've got 20 watts of dissipation on that KT88 there, on the low setting on the bias. It's drawing 71 milliamps. Let's flick it onto the high setting. Let's see, let's watch the scope. Well, that's let's see. There we go. This volume control is so sensitive. My word. It's like trying to align a radio. Right, so what have we got there then? And this is, remember, this is the powerfulest tube. So we have got 34.4 peak to peak. We divide that by 2, times it by 0.707, then we square that, and we divide it by 16. Are you ready? We get 9.24 watts out of this clean. 9.24 on the high setting. 9.24 watts. So not near the 15 as promised, but while we're on the KT88 now, let's crank this amp and see exactly what we can get out of it max. So it's flat, and so if we look, if I go back, you can see there we've got 41 volts. You turn it flat out, it drops. So 41 volts peak to peak. Divide by 2, 0.707 equals, square it, divide it by 16, and we have 13.12 watts, so not quite 15 watts. All we need to do now is check the bias on the high setting. So let's do that quickly. And I'm guessing that this is going to be the only tube that will be in the window for the correct bias on the high setting. So 34 divided by 307, which is the resistor, cathode resistor. We take 5% for the screens. That's blowing 105 milliamps. So now we need the plate voltage to cathode. Let's have a look. 398.88. We'll call that 399 volts. 41.9 watts that tube's dissipating. 41.9 watts. Let's just switch off. 41.9 watts. So what is the dissipation of a KT88? The absolute power of a KT88 is 42 watts, and we've got 41.9. So this amp has been set up specifically for that KT88. That's the tube that you'll get the best performance out of this amp. So what have we learnt from that? Well, all the other tubes really would only be safe to use on the low setting. So do I need to read the instructions again? So I've just checked on one of the video clips, and it clearly says 6V6 tube, low setting only. But all of the tubes that we've put in this amp are massively over biased, except the KT88. So this bias, this whole bias thing has been set up around the KT88. The other tubes on the high setting are just thrashing the 7 bells out of them. Obviously the 6V6s should be on the low setting, and they're at 14 watts. So that's been set up for the 6V6S as well at 14 watts. So make of that data what you will. Having said that, I still like the way this amp has been put together. I just think that the bias window could be improved on it, because you can't have, you know, output tubes 7 or 8 watts over dissipation. To me that's just, otherwise why bother with the data sheet? I mean, there's one thing pinching a watt, 1.5 watts, even 2 watts over, but you're talking 7 or 8 watts on some of these tubes. It's massive. So that leaves food for thought. However, that aside, we still need to now look at these resistors that we've got here and here, these plate resistors, which look very burnt. We'll just try and see what's going on with those. Right, I've just done the maths on those 200k resistors there, and the wattage comes out at 0.2 watts, so about a quarter of a watt, and those are half watts. Seems strange why they're a bit baked, doesn't it? Not sure what's going on there. As I say, maybe someone's had a bad tube in here or something with a short on. It's rare, but for preamp tubes, but I suppose you can get shorts on them. Maybe someone's, and then obviously because this type of amp is one of those amps, you know, where you swap in the tubes, maybe they've had it in this socket or whichever socket, they've had it in both of them, and maybe it's just baked them. I don't know, who knows, but they're baked. But we're going to unbake them with a nice 1 watt resistor. So another reason why we might not be getting the full 15 watts out of this amp is because it says 8 to 16 ohms on that tapping, and of course I've got 16 ohms dummy load on there as opposed to an 8 ohms. Right, so I've got an 8 ohms load on it now, and I've just done the maths on that, and we're getting 10.5 watts out of this amp, so a little bit more than we had before. We had 9 point something, I can't exactly remember what, but we've now got about 10.5. So that is the absolute max we can get out of that with this KT88. Right, so I found a schematic for this amp, and I found it on the EL34 forum. So we're going to have a look at this schematic, and one of the things I wanted to look at was this half power switch, and this is what we've got here. So we've got the primary coming in there, through there, and then we've got this secondary going on. We've actually got 2 tap-ins on this secondary going into a bridge rectifier. So we've got AC coming in here on that switch down to there, and we've got AC coming through there where that fuse is, and that gives us 1 tap in. So we'd presume that's the high setting, it could be the low, it doesn't actually say which is which. If we flick the switch the other way, then we've got AC coming in through there into that side of the bridge rectifier, and we've got then obviously the fuse side coming in. So you can see there 2 tap-ins going on. If we come along here, this is the DC now coming out, and we've got the standby switch there. That goes on then to the primary of the output transformer and goes into the plate. So that's all good. That's figured out how they do that. I was guessing they'd got a couple of tap-ins for that. If we look here, we've got our 300 ohm cathode resistor, which measured 307 ohms, 330 microfarad on the cathode bypass capacitor. So that's pretty high. So let's look at the inputs on this amp then. 100k plate resistor there on pin 1, coming in through this 68k grid stopper. We've got a 2.26k, which is almost similar to the Marshall 2.7. So this is looking very Marshall-esque. 0.68 microfarad as a bypass capacitor on that cathode resistor. So that again is very Marshall-esque. So if we come up here, 2.7 nanofarad there, and then we get to the other input. So this is very Marshall-esque. So this will be roll input, this is rock input. So we go through a 1 meg ohm attenuating resistor with a 470 picofarad passing the highs over it. And I think that'd be 470 on a Marshall JCM 800 if I remember. So that's standard coming into this next socket here, and you can see that that's bridged until you plug into that. So if you plug into this socket, disconnects this, and then that roll only starts its first stage here and doesn't use this one. So then we go on to there, and then we're going into a cathode follower here. By the look of it, that's all the EQ. So again, the cathode follower thing in the Marshall, the tone stack. So we've got that going on, and then we are coming out of that through a 6.8 nanofarad cap. We're going into the grid of V2B, coming out this 22, coming down here we've got a 100 ohm resistor and a 4.7k grid stopper there going on. R18 220k grid leak resistor with a 250 picofarad cap bypassing it. Interesting. Right, so I've done a turns ratio test on this output transformer. I'm really analysing this amp, and it's a 3k primary. So I've done some maths on the KT88, and on the low setting I'm getting 3.8k on the as the effective load resistance, which doesn't quite match up to 3k, does it? The KT88 on the low setting is 4k, which is slightly worse. But here's the deal with the 6V6S. The effective load resistance of the tube is 6k, which is double. And that's obviously on the low setting because we can't use that on the high setting. So the effective load resistance of the tube is double the primary on the output transformer. So none of that matches up either, and the other tubes are just, well, I'm not even going to bother doing the maths on those because it's totally irrelevant. All the other tubes really can only be used on the low setting apart from the KT88. They're all way over biased. So given that information we've got there now, we've analysed this amp, we've worked out, we've looked at the schematic, looked at the circuit, apart from the attenuator and all those parts. We're not really interested in those. But we've looked at the high and low switch. We know how that works. 2 tappings off the power transformer on the secondary side. Nothing surprising there. The rest of the stuff that we've done with the biasing of the different tubes and things sadly doesn't make this amp shine very well. Now, we've not listened to this amp yet. So far, my views on this amp is it's very, very well made. You know, if we look at the construction, if we look at the PC boards, the resistors that's been used on, on the really, it all looks good stuff. All the parts in this look, we've got metal film resistors in there, but I'm afraid the practice, putting this into practice, it doesn't quite stack up. I'm going to change these 2 plate resistors now that are burnt, or they're on the way to being burnt, and then we're going to plug this amp in and we're going to test it with all the tubes, but this time we're going to listen to it, and that should at least be a bit more of a fun part. If you found all this maths and things and whatever that a bit much, then I presume some of you's already scrolled on to the demo. Right, I've got it set up on the 4x12, and we've got the 6V6S in there, which is what we started with, so I thought we'd start with that too. Now I've got my glasses on because this font on here is unreal. So attitude is that pot that I couldn't read when it was on the bench. It's attitude. Let's see what it does. Just felt like a mid control or something, really. Just put a bit of it in. Right let's have a bit of a listen then. So we're in the rock socket. And I've also got that on single coil. On this as well, it's not particularly bassy sound on here. There's not a lot of bottom end on this amp. Now if we use this noise switch here, and we switch that in, it's working like a current limiter or something. That I don't know whether it's part of that hot plate. I don't know. Some looking at. So now we should be able to crank this amp now. Attenuator works really well. So that's pretty cool on there. So let's go into the roll. These switches, these sockets are tight. Let's go into the roll. Now the roll's using one less gain stage. And with this 6v6 in there, it's not very loud at all. I've now got that up flat out, and you can see it's quite. You do have to put the bass back in when you clean this amp up. My thumb's not working too well today with the arthritis, plus I'm a bit rusty because not played a lot, especially with a busted finger if you watch the previous videos. Right, let's get the, because now we've worked out what all the controls do on the amp while we've been on the 6V6, let's start putting in the other tubes. Right, now I've got this 6F6G in there, this Coke bottle, really old tube, which is, remember, 11 watts dissipation. Sockets are the clean one. That's flat out. Let's go into the rock socket. Somehow that tube just sounds better than the 6V6S. I wouldn't think there were that much difference between them. There seems to be a bit more clarity there. Try this. Let's crank this up on the old attenuator. And see how this tube first. Tune when I bought it. That seems a bit smoother to me. There we go, so that's the 6F6G tube. Right, I've got the 5881 in now, and there is a noticeable difference with that tube in there. Try that in the roll setting. My days, they're tight. That sounds much nicer. The trouble with that rock setting is when you plug into there, the amp's just trying to take off. It just wants to be a gain monster. The problem when you're using the roll one, where you've got one less gain stage, you're relying on you know, a bigger tube really to get your volume. That's a bit light on volume when you're using the 6v6s. About 16 watts out of that in low. There's a noticeable increase in volume. Let's just go back into the rock again and flicking the attenuator. Amazing how that sounds different with that tubing. Just seems a little more nasally with that tubing than it did with the 6L6s. Right, we'll wait for that to cool down and we'll try another one. Right, I've got this 6L6 GCR in there, and that's one with a dissipation of 19 watts, so we'll have a listen to this one. let's try it in the rock channel. We'll stick the old woofer on. And there's a noticeable difference with that tube. That sounds a bit harsh and a bit farty, so I think that's enough of him. So wait for him to cool down. I think the bin is probably the best place for that tube. Right, I've got this Russian 6P3S tube in now. Dissipates at 20.5 watts. Remember, some of these tubes are pushing up to there for dissipation, even on the low setting. Not put any of these tubes on the high setting because they're just being thrashed. You can see that's really bright compared to the last tube. Let's go into the roll, which is the channel I prefer. Well, not the channel, is it, but the... So more bass and a lot more cut on that one. And a lot brighter with that tube in, so that's a really nice tube. The last one we had was a really crap tube. So it just goes to show, you know, the difference between tubes. So I do like my Russian tubes, and that does sound really nice. But let's give it a blast on the attenuator now, and on the rock. As I go along, you know. So that sounds that's just lifted this amp. That just sounds so much better. So it just goes to show, you know, some people like Chinese tubes, and And you know, I've used some Chinese tubes that's been good, but that one's dreadful. But then again, you know, maybe it's been in an amp. It's obviously come out of an amp somewhere. Maybe it's been thrapsed, you know, and severely hammered. But that sounds great. That is a brand new tube, though, to be fair. Right, let's move on to the next one. Right, I've got this Softex 6L6 GC in there. 30 watts dissipation. I've just left the settings on this down to drop D. So that doesn't sound quite as toppy as the last tube, as the Russian tube. Let's try him in the roll channel. You just need to flick that attenuator off. Keep saying channel, but it's not really. Tube is really bright. It's got the treble nearly all the way down there. That's crazy. Let's just flick this one onto the high, because this is probably the highest dissipation. So when I flick this on here, it'll be over dissipated by 7 watts. And it really hasn't. Really hasn't made that much difference. In fact, made no difference. I switched it over. Onto the rock, just flicking that attenuator. Need to take the bass out. So on in the rock channel, it is noticeable. So noticeable, so we best not keep it on that too long and leave it in the low, because it won't last very long, being over biased to that extremity. So there we go, that's a 606 GC. So there's only one tube left now, and that's the beastly KT88. Right, I've got the KT88 in, and I just flick the attenuator off. And it was like somebody had shot me. That sucker is loud, really loud. Now that's on the low setting. Let's try the high. Still there, coming up in volume. Now that's a really smooth distortion tone there that I've got. That's a serious tune. And that is the best out of a lot of them, and I suppose in some ways it makes sense. You know, the effective load resistance is a closer match on that tube than the others are miles out. But that sounds great, that really does sound good, and that attenuator works absolutely brilliantly. So that works, that's awesome. Just flick that attenuator off. Now we're in the roll socket. Very attacking. Still a bit tender. Isn't working well today. So there we go, and that is loud, and unbelievably loud. It will be. It's, you know, that's dissipating at 47 watts, that tube. So you know, we're getting, even clean, we're getting, you know, nearly 10 watts out of this, and you probably don't think that's loud, but that is seriously loud, especially being sat in this room. So that's it. So that's demoed all the tubes, that's demoed the amp. So what are my thoughts now at the after just turn it off. What are my thoughts now after playing through this? Well, with this KT88 in it, it sounds phenomenal on the overdrive. The hot plate attenuator in it works absolutely fabulous. This noise reduction thing here with the light on it, I don't know, I just even bother with that, but that don't really matter. The high and the low setting, yeah, pretty advantage if you sat in here. You know, on stage you'd have that on high for the KT88. The Russian tube, the 6P3S, sounded great through it. 6L6 didn't sound bad. The rest of the tubes really, you know, so you're going to get, you know, the best sound you're going to get out of this is if you put a KT88 in. And to be fair, this amp's been modelled around a KT88. I do wonder, you know, whether this amp was designed originally for a KT88 and then someone said, oh, let's make this a multi-tube amp. That idea for me has not really worked very well. I don't think, you know, if this was my amp, I would just leave that KT88 in there. That's the tube that should be in this amp, in my opinion. But you've all watched it. That's only my opinion. You've all watched it. So, you know, leave your comments as usual about, you know, about all the stuff we've done, all the testing and whatever. So that'll do it for this one, because this one really has been a long one. And my playing's been a bit crappy in the demo, so sorry about that. Got some in my hands. So you all take care, and I'll see you all in the next video. So bye bye for now.